I can't have free here. And the first face. Um,
Guys, attendance enabled. We'll wait for a couple of more minutes. The attendance is still not too high. Okay, the attendance is not really improving much. I'll just wait till 2:05 and then we'll start. Okay, so we'll start. Just an announcement. This week the labs might not actually happen in the usual mode, but what will happen is in this semester I have assigned TAs as mentors for some number of students. Okay, and these mentors will be your mentors throughout the semester. So whenever you have any issues related to programming, I hope that these guys will be able to mentor you. And of course, I am there, so it's not like I am not going to respond back to your emails. You now have one more person to talk to, because sometimes it might be easier to uh, talk to another student rather than talking to the faculty member. So you now have another option, that there will be a mentor TA for each one of you. I think one TA has around 16, 17 people. So your practice labs will happen in general under the guidance of your mentor. And as I've already said, these practice labs are not compulsory to attend. You can actually be online and for 2 hours or so, and then I'll just give you some problem to solve. And you don't have to submit a solution for it. The idea is that if you are weak in programming, just try to solve those problems, and if you get stuck, ask the TAs to help you out. So this week the issue is that there is again a timetable clash. They have some engagements at the same time as the lab timings, so we have to make different arrangements to conduct the lab. We have found out some solution, but for that to be approved, it might take a few days of time. So this week, I've asked your mentors to send you guys an email, and they'll inform you that they are your mentor. And whatever question I'll give, you can do. You can try to write code for it whenever you want, and if you get stuck, just contact your mentor. Okay. Okay, guys. So let us start. So, in the previous week, we discussed that this particular course is going to be on building systems, right? I mean, data structures probably is a course which is going to help you out with uh, writing competitive programming code. But this course is all about building systems. So when we talk about building systems, there are certain concepts and certain conventions that you should be aware of. So the most important of those concepts or conventions is known as the software development life cycle, or SDLC. You will actually know more about SDLC when you study a course titled software engineering. But because we are going to do a part of the overall SDLC, right? I mean, basically one phase of the SDLC. Um, we are going to study some of it in this particular semester. So I'm just starting from the utmost basics, right? So just to give you a brief overview, don't worry much about it if you don't understand in its entirety. It is just to give you a brief idea of what SDLC is. You will study uh, details of SDLC when you take up a course on software engineering. Okay, let's start. So so one of the things that now you could see is that we have graduated from programs to the term software, right? In the previous semester, it was introduction to programming, so everything was about programs. Now the first term that we are encountering is a software. Okay, so how what exactly is a software? There are really no hard definitions of what is a software. In fact, when I grew up, the general concept that was there between in among the professionals was that anything that can be seen, right? Anything that can be physically touched. So it could be a mouse, keyboard, monitors. By the way, people used to call all of these things as part of hardware. Okay, even though technically it is not really hardware. But yeah, I mean, as I said, right, there is really no proper definition. Even I cannot say it is technically not hardware. But basically, all the electronic equipments that were there in a computer used to be called as hardware, and then whatever they cannot see with naked eye, basically your programs and everything, that was considered to be the software part. Okay, so this was how computer was made up of, right? The hardware plus software. This was a very old um, idea that people had. Today it's very difficult to even I don't think many people actually subscribe to these thoughts. But yeah, I'm just trying to give you the idea of how vague these terms are. So it's difficult to really give a very precise definition of what is a software. But for our purposes, we can have a very simple and short working definition. This definition is that a software is a collection of programs along with suitable documentation. Okay, this is a very short and simple definition. This definition talks about two basic things. First of all, instead of program, we are talking about collection of programs. Okay, so in the previous semester, towards the end, we did see some examples where the code was distributed across multiple code files. But in general, whatever code you guys wrote, it was all part of one single .c file, right? So in general, you can probably say it was basically one program that you wrote. And uh, when we talk about software, right? Software is generally a collection of multiple collaborating programs. The collaborating part is important here, right? It is possible that those programs might actually work independently as well, but but when they work independently, we really don't call them as software, to be honest. We call something as a software when you have a set of defined use cases, as in what exactly is this software expected to achieve. And then you have some collaborating programs which come together to somehow achieve the targets. The simple example is, let us say you open up VS Code. um, Typically in VS Code, right? I mean, I don't use VS Code, but basically in any editor there will be a number of things that are there, right? So there might be um, a way to open some file, right? There might be a way to save a file, compile a program, run a program, right? There might be so many other features that VS Code or any other coding editor has. Um, it's highly possible that this code is not written in one .c or .cpp or .py file, right? The code must be distributed, and usually each feature might actually have one or more different source code files. So this is the loose idea, that we are not talking about a single program now. We're talking about collaborating programs, and there is a collection of them. The second part is that a software is it is actually accompanied by some documentation. Now documentation itself could be at the code level. So you are encouraged whenever you go to industry. You in fact not just encouraged, you might actually be forced to write certain comments about your code, right? I mean, there might be an audit where someone actually opens up your code and checks if you have written ample amount of comments in your code or not, because it's important for your code to have comments, so that someone who takes it up from you, let us say later, is able to figure out what that code does. And the documentation is also done at different levels. Okay, so basically, before I start coding, I usually come up with certain documents which in some ways define the path of overall development. So this documentation part is important. We will actually do some of these documentation as part of your term projects. And yeah, by the way, that the plural of the term software is also software. So sometimes I might use the term a software or the term software. It's basically, the singular and plural thing. Okay, so when we are when we decide to actually build a software, right, what exactly is it that we do, right? This is something that you have to learn as a practitioner. Whatever skills you are acquiring right now, the ultimate aim of these programming skills is to become part of a team which ultimately builds software, right? So there are certain steps involved in building a typical software, a typical commercial software. Now again, there is a lack of clarity exactly what steps should be followed always. That is not really decided. But you can club all these activities together in mainly three phases. In the first phase, it's all about planning and analysis, right? So the first and the foremost thing that I must evaluate, let us say, as a project manager, or someone who's going to lead the whole team, is to figure out whether the project is even feasible or not, whether it is possible for us or not to build this software. Let me give you an example. Some of you might be just learning programming, let us say, using C. Some of you might even know C++. Some of you might also know things like Python or Java or other programming languages. Unfortunately, there is really no single language which is common across all the developers. So okay, so there's really no bare minimum or common minimum which each and every developer understands when he or she joins a company, an organization. So it is possible that I do have a team of developers, but I want to build the project, let us say, in Java, but all I have are C coders or Python coders. Okay, so even though they are coders, and it might they might easily pick up, let us say, Java over a period of time, but I'll have to figure this out, right? I'll have to keep this in my calculations, that no one in my team can understand how to write code in Java. So even though I have developers, I have programmers with me, the project might not really be feasible for me, maybe in the time constraints that we have. Similarly, it is possible that I am trying to do something, let us say, related to machine learning, and in order to build this project, I need some GPUs. Okay, and a GPU is actually a very costly hardware resource, by the way. So let's say if this project requires 5 GPUs just to test the code, whatever I'm writing, as an organization, or as a project lead, I may not have so much amount of money to be able to do this project. So the beginning in general starts with a kind of feasibility study, that I study whether this particular project is even feasible or not, given the constraints I have with me. The the next step, let us say, I realize that yes, it is feasible for me to do that. The next step then is to come up with some plan, right? So um, the number of people that will be working on the project, what is the typical amount of time I'm trying to target, um, how would the software look like at the skeleton level, things like this. So we come up with some sketches and documents, and these are more like a roadmap for building this particular software. The next step is to actually implement this. Now, if you remember in the previous week, I told you that the difference between, let us say, competitive coding and system building is that in system building, I need not actually show my coding skills. Okay, that is not really the idea. It's not system building is not about sharpening your own coding skills. It's about getting the things done. It's about achieving the functionality one way or the other. If I actually have a good library to do everything that I want, maybe in system building I will not write any code at all. I simply integrate that library and I say, yeah, I am done. Okay, I don't need to write any code for it. So this too has to be a part of the implementation. So generally, when we implement something, when we try to build something, when it comes to software development, we have to take calls, right? If there might be certain functionalities that could be provided to us directly by libraries and binaries, and we also might have to write some code. But the actual code that you will learn to write as a software developer when you go to a company will probably be glue code. So when I say glue code, it means that there are pieces out there. Let us say there are three libraries which achieve 70% of whatever you want. So the rest 30% might have to be written by you, but you write some glue code, glue that I know, as in that something that stitches together, and then with the help of the custom code that you have written, and let us say those three libraries, you come up with the final solution. All these things are part of the implementation, where you implement something, you test whether it works as expected or not. So all this goes in the implementation part. Once your implementation is done, then you have to either release your software, or you have to deploy the software, or sometimes it is both. So what is the difference between releasing and deploying? Basically, um, release is a term that is associated with products, software products, right? So for example, Microsoft may announce that the next version of Windows is going to be released on this and this date, or the next version of Microsoft Office is being released on this date. um, Deployment, on the other hand, is slightly different. So essentially what happens with deployment, these Indian IT companies, right, Infosys, TCS, and all these companies, they are usually more active in the service domain. So what do you mean by service domain is that they actually approach a client. The client in general, for instance, are banks. In the beginning they were all banking heavy, service oriented industries. So most of the clients of these you know these firms like Infosys and TCS and Tech Mahindra used to be banks. I'm not sure what is the current state, but um, still I think banking is the most dominant industry in which this our Indian IT industry works. So what they do is, in these cases, they actually approach a bank and they ask them that whether do you have any requirements for, let us say, automating your banking process or something else. And the banks will say, okay, fine, let us do that. So here is the project, here are my requirements, I want these things to be done. Please create this software for us and deploy it on our servers. Okay. So in this case, whatever software you build, it is different from, let us say, Microsoft Windows. It is probably built for example, the Royal Bank of Scotland, or for SBI. Okay, so this is custom software. We call this kind of development bespoke development. So in the bespoke development, you actually create software for a software solution for a particular client. So the software is tailored to the client's needs. Okay, it's not a general software like, let us say, Windows or MS Office. But in either case, whether you are building a product or you are going to deploy a service, let us say, for a client, the last phase involves deploying it, and then over a long period of time maintain it. So this is something that a lot of people, especially the youngsters, do not know about, that the major amount of money that at least our IT companies make these days is from actually maintaining these systems which are already running. Okay, uh, new projects are not that common. Okay, most of the time it's about maintaining, it's about support. Okay, so you have a software solution running, and then you charge your client a recurrent amount of money in exchange of giving them support for the software that you have built. So usually the actual amount of time in which you'll have to build the software is much smaller as compared to the amount of time for which the software will work. Okay, so maintenance is a very important aspect of software development. You have to build something and then you have to provide support for it. So this term called software development lifecycle, it actually puts out some phases. Okay, it says that if you are trying to develop a typical commercial software, not just commercial, basically any software, there are certain steps that you should follow. Okay, it's more like a guideline. It is not really it's not a binding. It is more like a guideline that these are some of the steps that you should do. So in the planning phase, for example, we begin by doing some kind of analysis of the requirements. We see if these requirements are even feasible or not. If they are feasible, then the next step is to come up with some kind of a higher level design. Okay, a bird's eye view to be honest, of the software. And then we keep on drilling down and creating more detailed designs until this is at a sufficiently detailed level that I can simply provide to my developers, and then ask them to start writing code. In some ways, this process is similar to algorithms and pseudocode, right? We started the programming from algorithms and pseudocode. I think we probably spent a week or a two before starting with the code. The idea was to first try to write an algorithm, then try to convert it to pseudocode, and then finally go to code. Similarly, when you are trying to develop a software, there are some design documents that you come up with, and once you have these design documents, only then you move forward and try to write code for it. In the implementation phase, of course, as I said, that the idea is to write code, but at the same time, um, try to figure out if there is another way to do the same thing, right? And this is something that might seem kind of anticlimactic to you, that you are learning so much of coding right here, but it is quite possible that when you go to industry, your job might not really require you to write stuff from scratch. Okay, most of the time you will be asked to use, let us say, an open source library to achieve whatever you want. Okay, and why it is so? Because whenever you write code, it's of course good that you write you are capable of writing your own code, but whenever you write code, um, we are all human beings. We can make mistakes. So the amount of testing that has to be done over newly written code or custom code is much more as compared to simply using a popular, let us say, open source library, right? Because so many people would have used it over a long period of time. If there were any bugs, they might have actually been repaired, so on and so forth. So the amount of trust that you may have on a popular third party library might be more than the amount of trust you'll have on your own written code. So in the implementation phase, the idea is to somehow achieve all the functionalities that we are targeting. It could be through writing custom code, or it could be through uh, you know in importing binaries and libraries. The testing part is also important, because whether, even if you are just importing libraries, there might still be some problems while integrating them together with each other. Okay, so in general, we do a number of tests when we build a software. These tests could be at various levels. So it could be, let us say, at a program level, or a collection of program levels, or communication between two collections of programs, at the level of the whole system. So there are many levels at which we test these software. You'll read more about software testing in software engineering. But in the overall idea of implementation phase is to achieve the functionality one way or the other. And then during the maintenance phase, of course, you deploy it at the client's end, or you release the software. Then over a period of time, let us say, if a few bugs were reported, you might also release patches, right? So you would have heard this term patch. So what exactly is a patch? Usually patches are bug fixes, that there is a product out there that you have released, but you've now come to know that there is some problem with that code. There is a bug in in that code. So you correct the bug, and then you release a patch. You say that please install this patch, and that bug will be removed, right? So all these things are part of maintenance. You continuously improve the software, you continuously repair the software. All this come under the maintenance phase. Now, SDLC is more of a philosophy. Okay, there are many models of software development. The simplest of the model is known as the waterfall model. Okay, the waterfall model. The reason for calling it waterfall is that everything is sequential in fashion, as if you pour water at the top of a waterfall, and it simply slides down. Rock by rock, something like this, for example, right? So the water starts falling from here, and then it simply goes on like this. There's no backward movement of water, for example, in a waterfall. So in waterfall model, the idea is that you start with the requirement analysis. Basically, you analyze the requirements that are associated with the software. You do some designing. Again, the designing is, as I said, right, it is equivalent to algorithms and pseudo codes. Then you do the actual implementation, you do some testing, and then finally the deployment and maintenance part. So one thing that you can see is that this waterfall model, um, it actually expects that your whole software is going to be built in one, what can I say, one cycle only. So you're not really going back at any point of time to any of these steps. So once the implementation starts, there cannot be any change in the design. Okay, things like this. So the waterfall model, it is the simplest model for developing software. But as I said, it is something that was probably the most elementary way in which people tried to formalize the software development process. But usually it is not that commonly adopted these days, because these days whenever we build software, we build it in small iterations. Okay, here everything is like one big iteration. Usually we build software iteratively, as in, we build some functionality, we deploy it, then we start another cycle, we build some more functionality, so on and so forth. But the waterfall model is the simplest model to understand, that this is how software development works. Now, in the whole SDLC as well as the waterfall model, the only thing that we are going to be concerned with in this particular course is the design phase, okay, and not even the complete design phase. We are only going to look at some of the ways in which a system can be designed, and the ways here are object oriented approach. So, what if I try to model my software as a set of some object oriented entities? Okay, so we'll look at what these object oriented entities are. But essentially the design phase involves creating two types of documents. The architectural documents, these documents are essentially higher level documents. Okay, they don't give you too much detail about the software, but yes, at a higher level you can understand, okay, this is what the software is supposed to do. This is probably the amount of hardware I will be requiring, so on and so forth. UML diagrams are usually used for doing a more detailed level design, where I create some design documents, usually sketches or diagrams, which can probably be directly understood by the developers. Okay, keep this in mind, that the developers are not necessarily so experienced that they can do this design on their own. So in most cases, it is going to be someone else, someone with great amount of experience in the industry, who is going to create these diagrams and then pass it on to the developers to actually build the system. So one such diagram that we'll learn in this course is known as the class diagram. And class diagram is basically a diagram which represents the relationship between classes in a software project. Now, what exactly is a class, we'll discuss it tomorrow, but this is just a simple example of a not so perfect class diagram. So just assume that, let's say you're given the task of building some kind of a portal on the triple ITL domain, and you are expected to have a system where students can register for courses. They can, the faculty members can put out content related to the courses. These are known as LMSs, okay, learning management systems. But the idea is that there are certain types of entities that are going to be there on this platform, right? There will be students, and there will be courses, there will be faculty members. Now, a typical student has some properties, right? As a student, you have a name, you have a roll number, the semester in which you are currently studying, And then there are some functions, you can say. Okay, basically the difference here is this: these are nouns and these are verbs. But these functions include registration. So for example, as a student, you might be required to register. As a student, you might be required to enroll in different courses. Okay. When it comes to course, the course has attributes like course ID or credits, the faculty who is teaching this course right now, the name of the course, so on and so forth. Faculty may have an employee ID. Okay. So essentially, these are the different types of entities that will be there in the portal that we just talked about. And there can be some relationships that might be required. So for example, one course might actually be done by multiple students, so this is why it says m is to 1. But in general, only one faculty is going to teach the course. For most cases it will be true. And one faculty will only teach one course. So I've just written 1 is to 1. It may not be required, but it may not be necessary. But yeah, this is the general idea. So these are basically some entities in my system. This is not code, by the way, right? This is just a diagram, or just a sketch, but it is helpful for someone who's going to build this system, right? So that person knows that, okay, I have to write some code to create courses, I have to write some code to create students, I have to write some code to create faculty members, and these are the properties that must be there in the code. And there are some relationships here that must be honored in my code. So this diagram, it is not really code, but it is probably going to be helpful for someone who decides to build this system. So these are the kind of things that we are going to look at in this course. This is, as I said, this is not the perfect class diagram. There are many problems with this, but this is a very simple example. We will have a look at how to create these class diagrams using UML. Now the last part of this lecture is the difference between imperative and declarative paradigm. So what do we mean by these? Basically, in the beginning of your course, in the beginning of ITP, uh, you wrote a lot of code, especially for creating these the solution for quadratic equation, right? Now, if you remember in that quadratic equation example, in the first iteration, I think we calculated everything within the main. Then probably in the second iteration, we created a function for calculating the discriminant, and then simply called that function to get our things done, right? So in some ways, this imperative and declarative paradigm, or way of thinking, it represents this. The imperative way says that you're not only concerned with what the result is, you are also concerned with how these results have been obtained, right? So you are not just happy with calling a discriminant function, you also want to see exactly how discriminant is being calculated. Whereas in the declarative paradigm, I only care about the end result. Okay, I want the discriminant to be calculated, whether I calculate it directly or whether there is a function for it. I don't care. Okay, so these are two ways. These are two ways to write code, and you can see that it's very difficult to differentiate between it. But this is a simple example. Let us say you are trying to calculate the factorial. Both these pieces of code are probably doing the same thing. It's just that here I'm actually writing the whole code for calculating factorial, and here I'm assuming that there is a function from a trusted library which can calculate the factorial and give it to me. Okay, so what is the difference? This part is in some ways representing the imperative approach, that not only am I looking for the solution, I'm also interested in figuring in showing how the solution has been reached. Whereas on the right, what you have is probably the example of a declarative approach. I don't care about how factorial is being calculated, as long as I'm getting the right answers, right? So there is, in some ways, there is a kind of a level of abstraction here, right? What exactly is this level of abstraction? At some point of time, I would say I don't really care about the details of the things, as long as I get the desired results. The classic examples are printf and scanf. We never really attempted to implement custom code for replacing printf and scanf, right? We simply used them. We never really thought about how exactly are printf and scanf working. So this is but for everything else we said no, I know we'll write the code. There are some people like these who would say no, I'm not going to use any library, I'm going to write my own code. But even those people might actually use printf and scanf. So this is the idea, that their level of abstraction is there, that I'm fine with using functions for input output, but for everything else I will write my own code. For some other coders, this level of abstraction might be even higher. Okay, so the coder might say, as long as I have a library function, I simply call the function and get my things done. Now this level of abstraction is not just at the program level, it is there at a general level as well, right? There are certain languages which are more friendly for, let us say, declarative approach as compared to imperative approach. Okay, so any language which has a rich library support for you is probably tending towards the declarative paradigm. So let's just say Java or even C++ is somewhere in between on this hierarchy. Okay, in this abstraction hierarchy, C is arguably below Java or C++, and MATLAB is arguably above Java. Okay, MATLAB is a very sophisticated language. It's probably a platform, you can't even call it a language anymore. So this idea of abstraction is a kind of a dilemma that as a developer you will always have, right? Whether I should write code for something or whether I should trust a third party library and simply use the results from there. So this is like just a difference between imperative. Any doubts? So there is some homework. You can have a look at it. So this is it. Do you have any questions? Please shoot now. Let me also check the chats. No, no, nothing in the chats. Any questions? Go ahead.
Sir, can you repeat what is patching?
Patching. So let us assume you wrote a piece of code, right? And in this piece of code, uh, you are not checking. It's a simple code. Let us say for dividing two numbers. Okay, one number from another. So you are taking input for the for the numerator, for the denominator, and then you're calculating the final value and simply displaying it to the user. Now, what if the denominator is 0? Okay, if the user inputs denominator as 0, then something untoward, something weird will happen, right? Your program will crash, or it will behave in a way it is not expected to. So but let us say you wrote the code and you've already released it, your user is already using it. So while in most cases it will work fine, for certain cases it might not work. Okay, and let's say someday a user says that I accidentally typed 0 and then it crashed. Okay, so this is in some ways a kind of a bug. So what is the way to change it? One way is that you basically replace that part of your code. Of course, replacing code itself is a very complicated process. I'm not going to go into the detail of how we do that, but for now let's just assume that you have the option of sending a new binary, a new a dot out to the user. So you simply say, okay, I have put an if condition in my code. If the denominator is 0, there will be some other way in which it is handled. The program will not crash. Okay, and then you say, this is a patch for the bug that was reported to us. Okay, in this, so if you install this patch on your system, that means you basically replace the old a dot out with this new a dot out. The problem of division by 0 will go away. So that is the idea of patches, that patches are essentially a way in which your existing code is modified or replaced in such a way that you actually do away with some problems that were detected. Okay, does it make sense?
So, sir, patch is a software or
Yeah,
say simply
yeah,
updates for an app.
Yeah, it's also a software. It's also a kind of so patching requires you to you to know exactly what part of the code is to be replaced. So there are ways to do that. Okay, you basically create another you essentially create another installable software solution. The user is supposed to install that, and during the installation you are going to change some part of the existing code on users computer. And after that those changes are made, when the user reruns your software, those problems have gone away. Okay,
Okay.
any more queries? So please bear with me. I know that you guys might have some expectations about seeing a lot of code in this course, but you have to understand that this is more of a design course. Okay, I'm trying to include the programming part by teaching you system building skills so that it doesn't become too boring. But yeah, the major aspect of this course is object oriented methodology. So it's a methodology course. So there will be certain lectures where we'll talk about philosophy and we'll talk about processes instead of actual code. Okay, so but please keep this in mind that these are all important for you when you'll go to some firm to do your internship, or after you join them as a full-time hire. These things will be important. You'll be expected to know all these things. Okay. Okay, any questions? Mm, okay. uh, so fast as in so because I didn't have too many slides. And by the way, please don't hesitate in these things, right? If you, for example, if I went through a slide and you were not able to understand it, you can the only thing that I can't do is check the chats now whenever we are having live lectures. But I'm always open to someone unmuting and then stopping me or asking me a question. I have no problems. Okay, so from whenever you I'm having these live lectures, if you feel there was a concept that I simply could not understand, you can unmute and say, can you please repeat that, or I have a doubt, I would like to know this. So please don't hesitate on these things. Just but the only thing is I can't read chats while I'm giving the lecture. So if you have a doubt, you'll have to unmute and ask. Okay, so this is for everyone. If you feel I'm going fast, if you feel there was something that I said that you could not understand, please stop and ask me to repeat. I have no issues. Okay.
Sir, you said that the waterfall model is not used like in the industry right now. Sir, which model is used? Like, is
Yeah.
it a
So
variation
yeah,
of it?
yeah. So basically, industry usually uses models like Scrum or XP. Um, the reason I do not want to go into the details of this is because this is specifically something that you will study in software engineering. Uh, the actual development process in detail. What is the difference between XP and Scrum, and how are they different from Waterfall? You will study in greater detail, but let me tell you why it is not used. Because the waterfall model expects you to have all the requirements associated with your software beforehand. Okay, so it's expected that you have all the requirements, and then you start with the design part. Once the design is finalized, you don't make any changes to it. You move over and do the implementation, then you test it, and then you maintain it and deploy it, right? Deploy and maintain it. The problem is, in most cases, okay, even the client, even the user is not really sure of what he or she wants. Okay, so and this is something that the industry has learned over a period of time. It's like they have learned it by getting burned, that while they are implementing the software, the user someday comes up and says, hey, I want a change in the requirements, I don't want this but I want this. Okay, but because you're following a waterfall model, it's very difficult now to do any changes, right? So what industry usually does is that they do these developments in iterations, in cycles. Okay, so it could be like a 15-day cycle or a 1 month cycle. So they pick up some requirements, they do some analysis, they write some code, they implement it, and then they show it to the user for feedback. Now the user might approve it or might suggest certain improvements or changes. Basically the risk involved is much lower in an iterative development process. So usually industry uses some kind of iterative development process. Waterfall is we basically study waterfall, let us say, from the historic perspective, that this is how software used to be developed. This is probably the first formal way in which we noted down these phases. But you'll seldom find this. Maybe you'll use waterfall model for your term projects, because that's a small project. We will not have the time to modify the requirements once they are finalized. So maybe in your term projects you will probably use waterfall model, but in general in industry you don't use it. uh, so the documentation, guys, the point is, let me just go back to that slide. So the documentation part, the reason we do this documentation, why is it that we do it? uh, just assume that you join a company tomorrow, and on day one you're told, and by the way this is highly likely to happen with you. Okay, um, on day one you're told that you are going to be a part of a team which is already working on some project, and now you are supposed to contribute to the project. Now the first thing you will have to do is read code. Okay, and uh, while it might be fun to write code, let me be very honest, most of the developers hate reading code. Okay, especially code written by someone else. Okay, this is why when you do this software development at a commercial level, you support the code with some non-coding literature, non-coding documents. Okay, these documents might be might be diagrams like the one I showed to you, right, the class diagram, or it could even be writing more comments within the code so that when I read the code I can understand it properly. So this is the idea of documentation. Documentation is describing whatever you are doing. Okay, code is basically whatever you have done, that is code, but describing what you have done is also very important. This is why you are supposed to give those demos after writing the code, right? Because just writing the code is not enough. If you go to industry, you are supposed to be able to explain to someone, and not just someone over a meeting. You are supposed to write documents. You are supposed to add add this stuff within your deliverables, that someone else who is going to handle your code later is able to figure out what is happening. So that is the documentation part. We will be using, yes, C++ for this course, and your at least whatever systems you are going to build in the term projects, that will be in C++. Okay, any other queries? Okay, so again, keep this in mind that the overall idea of this course is to train you for a different type of life. Okay, it's not going to make you a better competitive developer, competitive exam coder. For that, you have to do well in data structures. This is more about what you will have to do once you reach an organization. Developing an OS is also a system building aspect, but that is probably too large a thing. Developing any software tool, let us say I ask you to build a small text editor, that is like building a system. Okay, I ask you to write a small notepad like application, Can you build that? This is the idea. If you can, then yes, you know how to build systems. This is the idea. Of course, systems too are of very small to very large scales. Okay, so building large scale systems is an it's a completely different skill set altogether. You will learn these skills over a period of time, but in the second semester of your program, at least try to learn the skills that are necessary for building small scale systems. Okay, small applications. Any other queries? Okay, so keep this in mind that your TAs will be sending you emails regarding your labs for this week. I'll just give away some C problem tomorrow over email. So try to write code honestly for that, because these are all practice things, right? I mean, we are not evaluating this. So try to honestly write some code. If you get stuck, talk to your TAs. Okay. Any questions or shall we break? Okay, guys, then. Bye.
Thank you, sir.